So as I mentioned in the last video, keeping track of that name is super important. So before we connect our main geometry in, I want to see what's happening with the name attribute and make sure that we don't have anything that looks weird. So let's go up to the merge right here, Geo Spreadsheet, and as you can see, some of these entries do not have a name. So right away, that is suspicious. But it looks like as soon as we hit the grout, that exists as a point attribute. Up here in the primitive area, we also have grout as a point or as a primitive attribute, and it looks like the stone pieces are coming in as this piece name right here. So let's do a few things just to make sure that this works properly. First of all, I want to clean any attributes we don't need. Now, when you do this, you have to be careful because if you accidentally delete some kind of attributes that you do need, it can cause issues once it hits a solver. So let's just say remove everything, and we'll say let's keep our path because that's what our pack geometry needs to know where to point to. We'll keep any current name by saying that. And then on the groups, we also want to keep our stone group, so stones, as well as grouts, and let's also keep our normals. So that should clean everything up, and let's just do a clean on both streams right here. So if I middle mouse, we have name, position, path, normal in the group. Over here, same exact sort of thing. That basically got rid of this big pieces group, that got rid of this area that we use for the Voronoi fracture, the class, and looking at this, I think everything is doing just fine. Okay, so we still have this error here, and that's because we have the weird situation happening with the name. Now, my advice, as I mentioned before, is to have the same exact name value on the points as what you have on the primitives. So let's start with the stones right here. Right now, the stones doesn't have any name associated with the points. So let's use an attribute promote to fix that. Attribute promote, and let's go from primitives to points, and we will select name. Now, when you do this, uncheck the delete original. That allows the names here to stay intact, as well as what you just promoted to the points. Also, let's change this name. Instead of piece, let's use something else. So if we use a attribute string edit, this will allow us to change that name from piece to, let's say, stones. So we'll say take the name on both the prims and the points, and we want to go from keyword piece to stone. If we check on this use regular expressions, that will do what we want it to do. So now we have stone and stone for both the points and primitives. Okay, so that's looking much better already. Let's do the same kind of thing here for our grout pieces, except this time we are going from point to primitive. So now we have the same name. I believe this is already called grout, so we have that going on. In the assemble node, if you say grout as the prefix right there, then that will name it like this. If I haven't already mentioned that before, that's one way to make that happen. Okay, so this all goes to merge. And that also got rid of our error, which is great because that means we're keeping everything really clean and there's no weirdness happening there. Okay, cool. So let's bring that into the merge and also clean up our constraints before that enters into the DOP as well. So again, use a clean, remove everything, uncheck these options, and remember what a constraint needs. A constraint needs the constraint name that we mentioned in the prim and wrangle, and we also need the name of the points so that it knows where to go. Also, let's, we can actually remove all groups, that's fine. Okay, so now we just have the name. Again, that's the piece, constraint name, that's the kind of constraint, and I think that is everything that we need right there. Okay, great. So let's now go to the DOP.NET. I've already set up a very basic situation that was based on what I taught you before. It's just an RBD packed object we're going with the first context geometry. In the bullet data, we're using a convex hole. And then we also have this constraint network, which we will use with a glue constraint relationship. So on here, the data name, again, that's the constraint name that we want to find. Let's say we want to start with the grout constraints. And actually, I think I camel cased it like that. There we go. Also, let's turn off our display geometry on the RBD packed object. And as you can see, the constraints are coming in just fine. If you don't see these red lines though, then that means that there's something wrong and this glue constraint is not picking up the info it needs. So if we have that, let's just call this our grout constraints, and then this can be our stone constraints. We can just merge these two together. So we can go like that. And right here, we will just replace grout with stone. Okay, awesome. So that is working pretty well. Let's also check our convex hole, our collision shapes, before we continue. So I'm going to check this show guide geometry, and it'll take a minute, but this will show us the actual collision shapes that Bullet's going to think about. And here are the convex holes that make up all the pieces. Now, one great thing about Bullet is that even though these pieces are overlapping, it's smart enough to know that at the beginning of the simulation, if something is overlapping, it's not going to freak out and think about it. The only time it's going to collide with the other pieces is if it progresses forward in time and it just met a new object that it wasn't overlapping to begin with. And so because of that, that's why we're able to get away with all these different pieces jammed into each other. And if we go ahead and press play, boom, look at that. Really cool. Gravity is pulling down on these pieces, and that's what's causing it to crumble and collapse in a really cool way. However, this obviously is not ideal. We want the wall to stay together, and then as Eugene hits the wall, that ends up breaking it. So we'll talk about that. Also, similar to that idea, as you can see, the constraints, they just kind of go away on their own because of gravity. So we'll adjust what's happening there so it doesn't do that. Before we get there, though, I want to talk about caching this out and how we're going to eventually render this. And there's actually a few things that you need to know. Okay, so first of all, you might think, all right, well, I like the sim, let's say, and I want to get the object and cache it out. So you might think, okay, DOP network, I want to grab anything that says RBD in the object name, so star RBD star, right? That'll get you that RBD packed object. And then, you do a file cache and we're good to go. But there's actually a much better way of doing this. So instead of doing it on the DOP.NET like this, let's use a DOP import node. And we're going to use this import style as create points to represent objects. So now, if I go here to the DOP.io and we drag over this DOP network, we just have those packed pieces, they're points, and they're all situated like this, and that's how they move around. So when we go to cache this, we'll say file cache. All we're caching out are the points. And that's really awesome because that's not a lot of data to cache out. These file sizes are going to be very small. So let's call this our, we'll call this our destruction 1 simulation right there. I'll say hip geo $os $os.f4.bgeo.sc. Save frame range. Let's go ahead and just do a couple hundred frames for right now and save that to disk. Once you do that, you read in the points like I have here with this file sop, and we'll use a transform pieces sop right here. The geo to transform and the template points. That's what we need to make this work. So we have the template points. That's the sim read. Let's use an object merge to bring in what we had up here with this merge. That's all the original pieces. So there's the original pieces. That's the geometry to transform. It finds all of this via the name attributes. And now we have something like that. In the next video, let's move on by stabilizing this wall and making it so that it doesn't crumble with gravity. And then we'll also bring in Eugene to crash through and make his grand appearance.